All right, now on this factoring, there's going to be more than one step. It says GCF, then dots or trinomial. Now, whenever you have to factor anything, the first thing you always want to look for is a GCF. The little bit that we practiced in class, I didn't throw any GCFs at you, but if you're just told to factor something, always look for a GCF first. Now on number one, you can divide each of these by 5. Now what this looks like, put your GCF out front, just like I told you before, and then, 5 divided by 5 is 1 v squared, you don't need the 1. 35 divided by 5 is 7. 60 divided by 5 is 12. So that part was just the GCF. Now, what we're doing right now is kind of similar to say you had to factor a 20 back in the day when you did factor trees, you do 2 times 10. Oh, but then, hey, you can keep going. You can break that 10 down into another 2 times 5. Same idea here. What I got in the parentheses is a trinomial. Now I can factor this like we had learned in class, what 2 numbers multiply to the number on the end, and forget about the 5, the GCF. Forget about it now. Pretend it's not even there. What 2 numbers multiply to 12 and add up to 7? 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So you got... I only factored that trinomial right there. Then, just like you would do over here on the tree, you bring all of them down, and factoring breaks stuff into multiply, you got to bring the 5 down. Now, you don't draw the times sign or the dots, but really what this is 5 times v plus 3 times v plus 4. So that one was a GCF, then it turned into a trinomial. 2 here, 5 divided by 5, 1, x squared, so I don't need the 1. But 5 divided by 5 there, I gotta have that 1, because there's nothing else. Like there's no x there, that I can say 1 times x is x. Here, 5 divided by 5 for the second one, you just gotta leave it 1. Then you recognize, oh, hey, I got a perfect square, a minus sign, and a perfect square. That's dots. Difference of 2 squares. Difference means minus. 1 gets a plus, 1 gets a minus. The square root of x squared is x. Square root of 1 is 1. Then just bring the GCF down. And it was a coincidence that it was 5. Like on 3 here, divide those all by 4. 24 divided by 4 is 6. 20 divided by 4 is 5. Forget about the 4 for a minute. Oh, got a trinomial. Now be careful with 5 and 6. We want numbers that multiply to 5 and add to 6. Don't use 2 and 3. 2 plus 3 is 5, not 2 times 3. 5 is prime. So use 5 times 1 or 1 times 5, either way. Now again, I said be careful on that one. When they throw a 5 and a 6 into factor, since 2 plus 3 is 5 and 2 times 3 is 6, people will sometimes accidentally use 2, 3 in the wrong time. Now, here we just now got to drop that 4 down. Done. Number 4, 3, 9, and 120. I can divide those all by 3. 3 divided by 3, 1, so just n squared. 9 divided by 3 is 3, and 120 divided by 3 is 40. Got another trinomial. My number on the end is negative. So one's a plus and one's a minus, because a positive times a negative is a negative. Then you need two numbers, multiply to 40 and subtract to 3. Now, since that 3 in the middle, then minus 3n, since that's negative, the bigger number has to be negative. And since they're opposites, it's like they subtract to 3. 8 times 5 is 40. 8 minus 5 is 3. So we got the right numbers. Just make sure the bigger number, the 8 goes with the minus, and the plus goes with the 5. And you could have the n minus 8 first, and then the n plus 5. That's fine. Just as long as the minus is with the 8. And then don't forget, bring the GCF down. And a lot of times, not always, but a lot of times when a problem has more than one step, there is not an x in the GCF. Sometimes there is. Most of the time there isn't. 5 here. We can divide those all by 3. 24 divided by 3 is 8. 27 divided by 3 is 9. Trinomial again. And again, the end is negative. So a positive times a negative is negative. We got to have one of each. We need two numbers that multiply to 9, and since they're opposites, it's like they subtract to 8. Well, 3 times 3 is 9, but 3 minus 3 is 0. That doesn't work. 9 and 1. 9 times 1 is 9. 9 minus 1 is 8. Just make sure that 9, the bigger, goes with the minus. And bring the 3 down. 6, yeah, another 3. Now, 3n divided by 3 is 1n. I'm not going to write the 1 down. Now, if you don't write the 1 down there, it's fine. Just don't forget there would be a 1 there. Sometimes people get confused when they're factoring if there's no number in the middle. Just remember, n is like 1n. You don't have to write that down. If it helps, though, write it down. So I need two numbers, multiply to negative 30. Hey, I'll change it up this time. I'll put the minus first. 5 times 6 is 30. 6 minus 5 is 1. The 1n is positive here, so the bigger the 6, you got to have the plus. Bring the 3 down. Oh, this time the GCF's back to 5. 5 divided by 5 is gone. You can write the 1. You don't have to. 80 divided by 5 is 16. And then you think, hey, that's 2 terms. It's a difference. It's a minus. And they're both perfect squares. Forget about the 5 for now. I got a squared minus 16. That's dots. 1 gets plus. 1 gets minus. 4 is the square root of 16. Bring the 5 down. And on 8, this time we got 4. We can divide those all by 4. 8 divided by 4 is 2. And then now 192 divided by 4 is 48. Back to a trinomial. Now I need two numbers that multiply to 48 and subtract the 2. 8 times 6 is 48. And 8 minus 6 is 2, but it's got to be negative 2. So the big one, the 8's got to go with the minus. And you could have the n plus 6 first, and then the n minus 8. That's fine, as long as the plus is with the 6 and the minus is with the 8. Then don't forget to bring down the 4.